Okay, and we are back. Now last time we learned all the ways that we can prove that two triangles are definitely congruent. You did an investigation and learned about side, 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 angle, angle, side, angle, angle, side, and that new one, hypotenuse length, that has to do with right triangles. And we also saw that angle, side doesn't prove, and angle, angle doesn't necessarily prove, so we can't use those two. So now we're going to see how to utilize these to solve some problems. Alright, so I have some problems here for you. There we go. So if you take a look at this first one here, right, we have two triangles, and you can see these markings. This means that this side is congruent with this side. That's what that one dash means. These two means this side is congruent with this side, and this side is congruent with that side. So we have three congruent pairs of sides for these two triangles. I like to label it. I have a side, and a side. So you can see that now I have enough information that I can prove that these two triangles are congruent. So we can say yes. How? By SSS. Okay? Let's take a look at the next one. It looks very similar to this one, but you'll notice that the two triangles are touching. They're sharing this side here. Okay? So what we can do is we can think, can we mark anything on this picture? That's what you want to do first, is you want to mark something first. In this case, we have two triangles and they're sharing the side, so it's nice to actually mark that it's congruent with itself. And the reason is, then we can say we have this pair of sides that are congruent, S, this pair of sides that are congruent, S, and then this is congruent with itself for the two different triangles, S. So again, this is the same type of problem. Yes, by SSS, we can prove that these two triangles are congruent. So if we can do a little marking on the picture first, we want to do that. Alright, take a look at this one over here. Again, reviewing what these markings mean, right? We have two pairs of sides that are congruent, or one pair of sides that's congruent, excuse me. These two angles here are congruent, and then these two angles here are congruent. You see that? So we have an S here, an A here, and an A here. Now notice I don't have this A and I don't have this side, so the order that I do this in is important, okay? I can do it in either order, but I can't skip over right here. I don't have this information, so I have to do it actually in this order. I can't do it in either order in this case. It has to be A, S. So it's yes by A, S. If we did ASA, that would imply that we would have an angle, a side, and an angle all next to each other, but we don't have that. We have angle, angle, and side. So it's yes, AAS. Alright? Take a look at this one over here. Now, again, we have two triangles that are touching. A lot of times you can mark something if that's the case. Do you see what I might be able to mark here? Take a look. Okay? Do you see right here, there's two intersecting segments, so I can mark two angles. Do you know the name of these two angles here? They're vertical angles, and since they're vertical angles, we can mark them as congruent. Okay? So now let's see if we have enough information. We can't mark anything else. Let's see if we have enough information. We have angle, side, angle. Right? So yes, we can prove these two triangles are congruent. How? ASA. Alright? So moving on to our last two in this example. One down here. So we have a right triangle here, so it might be hypotenuse leg, because that's available for only right triangles. Let's take a look. We can mark something here. Do you see what we can mark? Yeah, you see that they share this right here. So I'm going to mark that as congruent with itself. I use two dashes because one dash is already used. Right? So let's see what we have. Oh, and there's one other thing we can mark actually. If this is a straight line and this is a right angle, that must mean that this is a right angle as well. Okay? So we have side, angle, side. Right? You see that? SAS. Yes by SAS. Now notice it can't be hypotenuse leg because this is the hypotenuse opposite the right angle, and we don't know anything about that. We don't know if it's congruent with that. Okay? This last one, we have two triangles intersecting here. Do you see what we can mark? Yeah, just like this one up here, we can mark these as vertical angles. See that? Can we mark anything else? Yeah, so we have a parallel line here to this line here, two parallel lines cut by this transversal. Since we have parallel lines cut by a transversal, and we care about the angles on the inside of the triangles. So you can see that this angle is going to be congruent to this angle down here, right? Those two angles correspond. They're corresponding angles. Okay? Now, and then this is a vertical angle to this. So those two angles are also congruent. Another way to think of it is this is the alternate interior angles to this. See that? So now we have another pair of congruent angles. In the same way, we have two parallel lines here. If we extend this, you can see that this is another transversal, right? So you can see that this angle is the alternate interior to this angle, right? Those two are going to be congruent. Right? So we have two triangles. We have three pieces of information. It looks like we have A, right? Oh, but that is not one of the ones that we can use. Remember, AAA isn't allowed. Do you see why? Because these may be similar in shape, they're similar triangles, but if all we have is angles, they may be different sizes. Actually, it even looks like this is slightly smaller than this one, according to my drawing. So this is a no. We cannot prove congruence. Alright? We're going to take a quick look at two more that are a little bit more complicated. Okay? So, here, we have a shape here. Do you remember what this shape is called? It has parallel sides here and parallel sides here. You know what that's called? Yeah, this is a parallelogram, and this is one of its diagonals. So, we're going to see if we can prove that these two triangles that make up the parallelogram are congruent. Alright? Now it has to do with these parallel lines, and we'll get to these in a second. So if we extend these parallel lines here, you can see this is a transversal. Right? I'll extend that transversal. And in the same way that we just did, right, I can say for these parallel lines cut by this transversal, this angle is congruent to this angle. Right? Alternate interior angles of a transversal with parallel lines. Those two are congruent there, right? And in the same way, if we extend these parallel lines, now this transversal cuts through these parallel lines. So, do you see the other pair of alternate interior angles? This and this. So this angle is congruent with this angle. See that? Do you see anything else we can mark? Yeah, this is congruent with itself. So let's see what we have. We have angle, side, angle. Is that one we can use? Yes, it is. So this is yes by ASA. Alright, last one. This looks very similar to what we just did. Do you see the only difference? Right? These sides are congruent. Okay, up here, these sides were parallel. So let's see what we can do here. Alright, in the same way, we can extend these parallel lines. We can extend that transversal. Now, do you see the alternate interior angles we can mark as congruent? Okay, we have these two lines are parallel, and this is my transversal. Okay, so I can't do this one because this isn't parallel necessarily. I have to do this one here. It has to touch the parallel line here. In the same way up here, it has to touch the parallel line. So this and this are alternate interior angles. These are parallel lines, so those are congruent. Okay? Now these are not necessarily congruent, so I can't mark the other two. Alright? Do you see anything else we can mark? Yeah, again, just like up here, we can mark that this is congruent with itself. And I use 2 dashes because that 1 dash is already used. Alright, so now let's see what we have here. Within one triangle I have A, and then I have S, and then I have S. You see that? A, S, and S. I don't have this A, so I can't say that. So, I have angle side side. Is that allowed? No, that's not one of the ones that we can remember, that can prove congruence, right? Because there was an ambiguous case with that. So we can't use that. That way we know this is a no. These may be congruent, but we cannot prove that they are. We don't have enough information to prove that they are. I hope that that was helpful to you. I think you're ready to try a bunch on your own. Good luck.